Okay, on the quiz last week, there was a little confusion about recursive definitions versus explicit definitions. If you look at these really carefully, these two definitions both specify the exact same sequence. Let's see how they work. So if I work with the top one, I have the first term is 11, and then each thing is defined to be 3 more than the previous term. Okay, that's what this means. A sub n is 3 plus the previous thing in the sequence. Okay, so it'd be 11, 14, and then add 3, 17, then 20, you get the idea. Okay, dot, dot, dot. So this one, let's go ahead and plug in A1. A1, it's going to be 8 plus 3, so again 11. Okay, I plug in 2, then I get 8 plus 6, that's 14. Then I plug in 3, I get 8 plus 9. So I get the same sequence out, you see. So the only difference is how these sequences work. Okay, so this top one has a starter value, and then each thing is defined in a way that relates it to the previous thing. Okay, so let me describe that. So recursive definitions, the way they work is they give a start value, okay, and then after the start value or values, each new sequence member is defined in terms of previous members. Okay, all right, so in other words, usually the way it looks like is a sub n is equal to a function of a sub n minus 1, but you might see that it might be different. There might be a couple different ways of doing that. An explicit definition, what that does is it jumps directly to whatever term you want. So I'll say to any term. Okay, so explicit, you could jump to the millionth term just from the definition. Whereas the recursive sequence, you have to build your way up there. Okay, so this first one, again, is a recursive sequence, and this one is an explicit one. Hopefully that makes it clearer, but I think if I show you one other sequence that's kind of cool, it'll all solidify very well. Okay, so this is called the Fibonacci sequence. And the way it works is it starts off with the numbers 1, 1, then you add those together and then you get 2, right? And then you add 1 plus 2, then you get 3. Add 2 plus 3, then you get 5. Add 3 plus 5, then you get 8. Add 5 plus 8, you get 13. And you go so forth onward. Okay, so how that has to be defined is recursively, because the way it works is everything's defined in terms of previous things. This one actually needs 2 starter values. So the first one is 1 and the second one is 1. And then here's how it works. If I want to find the nth thing in the Fibonacci sequence, I have to know the n minus 1 thing and I have to know the n minus 2 thing. Okay, so if you see, if this is where I want to be at, I have to add the n minus 1 thing, which is here, and the n minus 2 thing. So this would be like the recursive setup for defining the Fibonacci sequence. Let me show you one other example that you've already seen that kind of relates this concept. If I want to generate Pascal's triangle in order to expand out, say, x plus y to the 100th, one way to do it is to build it up like this. Okay, this would be a recursive process because I'm doing it step by step. Each row depends on the previous row, right? Okay, whereas if I just jump to like 100 choose 0, 100 choose 1, 100 choose 2, etc. to 100 choose 100, and I use this formula for generating the coefficients I need for expanding x plus y to the 100, this would be explicit because this jumps exactly to what you need, whereas like this first one, you have to build your way up to what you need. Both sequences are useful. As you see, sometimes you can only define something recursively, and so that's a definition you should be aware of, even though, you know, the explicit is much more useful.